اهلا بيكم مره تانية في كايرو دار اعزائي طلبه الثانويه العامه. النهارده هنستكمل مع بعضينا رحله الميكانيكس ودرس الفريكشن. As we know that we are talking before about the friction of the friction force, and we denoted as some kind of resistance force, and it must be in the opposite direction of the motion. Now we have to complete the lesson that are talking about the friction again, but now we will talking about the friction in the inclined plane. Then our lesson today will be friction, equilibrium, of a body on مع بعضينا بقى كده rough inclined plane. طبعا احنا عارفين if we have a body like that, this is the body and rests in an inclined plane, we have some kind of forces act in it. If a body put on a rough inclined plane and it's about to begin motion down the plane under the effect of its weight only. تاني كده نكتب الجملة دي. The body is about to what? To begin the motion under effect of, yes, effect of its weight only. ايه اللي هيحصل؟ نركز كده مع بعضينا. طبعا احنا عارفين ان الويت acting downward vertically. If this is theta, this is the angle of inclination, and we have here is normal reaction. Now don't forget to write this is again theta, and this is the component of weight. This is W cosine theta, and this is W sine theta. So the motion according to the effect of the weight must be sliding downstairs or downward of the inclination plane. Then that means that we have the friction force must be in this direction. Okay, نخلي بالنا من شوية نوتس كده مهمة جدا. The measure of the angle of what? The angle of inclination. Equals or is equal to the measure of the measure of the friction angle. طيب تعالوا نحط نوت كده صغيرة. The measure of the angle of the inclination, angle of inclination دي means theta اللي هي دي right equal the measure of the friction angle اللي احنا كنا بنسميها لامدا. طيب تعالوا نفتكر حاجة، مش احنا عندنا الميو ده coefficient of friction as we know that mu equals tan lambda and now here lambda is equal to theta, then tan lambda equals tan theta equals mu. So we have some definitions that we have to know it very well. What's the meaning of the lowest force? This is according to the inclination. What's the meaning of the lowest force? So the lowest force, this force which makes the body is equilibrium in or on a rough inclined plane. And stop its sliding down the plane. Like what? Like the braking force when you drive a car and we are in the bridge or an inclined plane like that. So the smallest force, the lowest force that keeping the body or keeping the car don't slide down the inclined plane, that's some kind of friction force or the lowest force. Like what? That you have to press the brake of the car. This is the lowest force. This is the lowest force. Then what's the meaning of the lowest force? According to the inclined plane, the lowest force, this is a force which make the body is equilibrium on this rough plane to keeping it don't go downward the plane or don't make it not sliding downward the plane. So we have another definition which is the greatest force. As we have lowest force, now we have greatest force. What is the greatest force? This is the force which makes the body is about to move up the plane. So we have to try to solve some kind of problem now to make a good recognition about the friction of the inclined plane. First we have to read it. If a weight of 16 newtons on a rough inclined plane, it's noted that the body is about to begin motion down the plane under the effect of its weight only. Under the effect of its weight only means, right, we have to make the resolution of the weight on the perpendicular plane, W cosine theta and W sine theta, and that leads also to put the direction or the right direction of the friction, which will be parallel to the greatest slope of the plane. We will see it together now. When the plane is inclined to the horizontal with an angle whose sine is 3/5, find the coefficient of friction between the body and the plane. Find also the measure of the angle of friction. We have now to write down together the given of the problem. First, this is example number 1. Again, a body of a weight 16 Newton. Now we have W equals 16 Newtons. Also put on a rough inclined plane. It's noted that the body is about to begin down under the effect of weight when the plane inclined to the horizontal with an angle whose sine equals 3/5. That means sine theta equals 3/5. Now he need to find mu, it's unknown, the coefficient of friction, and now measure of the angle of friction, and lambda also unknown. Okay, let's try to draw. This is the inclined plane, and now we have our body here rests in the inclined plane. Now we have to draw, this is theta, and this is the weight, and this is the normal reaction. The problem said that the body will move under the effect of its, yes, weight only. Weight only, that means we have to sliding downwards. This is W sine of theta, and this is mu r. Now we have W cosine theta. So, as we know that sine theta, we have to draw right angle triangle like that, and sine 3/5, this will be 4 because this is theta. So we have now cosine theta equals 4/5, and we obtained the value of cosine from the given sine theta. So we have to solve now. This is the solution. So all previous steps, this is the translation of the given of the problem. Now we have to write down our mathematical equation. Firstly, mu r equals 16 sine theta, because mu r equals W sine theta, and W is 16. So we have to substitute by mu and r if we have each one of them, and the other equation will be r equals 16 cosine theta. I think the second equation much easier to be solved. So r equals 16, substitute about of cosine theta by 4/5, then r will be 64/5. So make the replacement. So mu r now is 64/5. This is 16. Also sine theta is 3/5. 5 crossed out was 5, and now we can get by calculation mu equals, yes, equals 3/4, and this will be the first request. The value of mu is 3/4. We can use this small space to complete the second request. He need now the value or the measure of the angle of friction. We know that tan theta equals tan mu equals lambda. So we can use directly this way before we use the steps. Of course we can do it, but we have to learn together step by step how to get or to make the relation between mu and theta and lambda. So now tan lambda, this is lambda, tan lambda, and this is mu. So tan lambda equals 3/4. By using calculator we can find that lambda equals 36 degrees and 52 minutes, and this is the first, that was the first problem that we have to know how to find out the unknown when our body is equilibrium on a rough inclined plane, how to determine the direction of each of the component of the weight, and also the direction of the friction force. Now we have to move to the second problem. This is example number 2. Let's read it together to get or to find out the givens. A body is placed on a rough inclined plane, making with the horizontal an angle of measure 60 degrees. The coefficient of the friction between the body and the plane is √3/6. Show with reason that the body will not stay in equilibrium. This question here can be formed by another way, or he want to know if the friction force here is limiting or not limiting. So if it's ordinarily friction force, so what about the limiting force or limiting friction force? So we have to make a comparing to know or to show the other if the body will stay in equilibrium or will begin to move. First we have to write or to draw the problem. Our problem is this is an inclined plane, and again we have to write this is our body here rests on this inclined plane, and also we have this is angle 60 as he said. So theta now is 60. This is the first given, and this is a component directly. This is W and this is R. Now we have to W cosine 60, don't forget to write here 60, and this is W sine 60, and we have P. Now P is the friction force. It could be mu r or not, so we have to write the equation of equilibrium. R now equals W cosine 60, so R equals, this is W, what about cosine 60? It's half. Now we have to, or we reach to the value of the normal reaction. R equals half W. It depends on the value of the weight. Second, we have to write the second equation. This is the horizontal. We have P equals W sine 60. Now it's B equals W sine 60. That means B equals √3/2 W, and this is the force of reaction. So sorry, friction force. This is friction force. Okay, so what do we have now? We have to make a comparing between, do we have, is it limiting or not? Let's calculate mu r. Mu, this is √3/6 times r, which is half, W. So mu r now equals √3/12 W. this is P and this is mu r, the limiting. This is the friction force and this is the limiting friction, as it's shown that root 3 over 2 W is greater than root 3 over 12 W. That means an friction force greater than mu r. The friction force is greater than mu r. يبقى ده leads us to say that the body is not stay in equilibrium. Do you understand, my dear? Okay, let's move to another problem. This is a good problem. Let's read it together. A body of weight, this is example number 3. Body of weight 76 newtons is about to move under its own weight when placed on a rough plane, which is inclined to the horizontal with an angle whose tangent is 1/4. Firstly, we have to write it or to draw. This is inclined plane and this is a body. This is its force of weight 76 and this is the normal reaction. Now we have 76 cosine theta and we have 76 sine theta, and don't forget to put mu r, the friction, because the body is about to move. Now we have, this is theta, and he says that the tan theta equals quarter. Okay, some kind of pupils or students can say that we have to write down both of equations, the horizontal and the vertically equations, to get out or to know the real value of the unknowns, and this is right way to, or right method to solve the problem. But let's try to use our mind directly. We said that if the body is about to move, that means the angle of inclination of the plane equal the angle of the friction angles, both of them equals mu, then tan theta equals tan lambda equals mu. So we have to save our time and our steps, and directly we can say that since tan theta equals tan lambda equals mu, that leads us to get the value of mu, which is equal 1/4, and this is first directly, because we know that very well. But if we can't remember this point, so we can use the other way of the solution to get out the equations to solve it together. Okay, so what happened now? The second part of the problem said that if the body is placed on a horizontal plane which is as rough as the inclined plane, that means that we have the same coefficient of friction. Mu will be equal, doesn't change. Okay, again, if the body is placed on a horizontal plane which is rough as the inclined plane and it's acted on by an upward pull in a direction inclined to the horizontal with an angle whose sine is 3/5, so that the motion is about to begin. Find the magnitude of this force and the normal reaction. This is very important part. Let's use another tips like that. We have now W equals 76 and we get that mu equals quarter, and now we have to write the new figure. This is a horizontal rough plane and this is the write this is our body and this is the weight and this is the normal reaction. Now we have to, he said that the body is pulled by a force F, inclined here by angle theta, another theta. So we have to write now, or to make a resolution for F, resolve F to be here F cosine theta, and here is F sine theta. Don't forget to write mu r. Now we have to solve. This is sine theta equals as a given 3/5, so we have to use cosine theta equals 4/5. The first equation is r plus f sine theta equals w. Also we have f cosine theta equals mu r. Shall we make a substitution? Here in the second one, mu is quarter, this is r, equals f, and cosine theta is 4/5. That means r equals 16/5 f, and this is the relation between r and f. We can use it here. R equals 16/5 f plus f sine theta equals 3/5 equals w, which is 76 newtons. So 16 plus 3, it's 19/5 f equals 76. That means by solving this equation that f will be 20 newtons, and we get now the real value of f. So we have to return back again to get the value of r. So r will be 16/5 times 20. That means r equals 64 newtons. And now we get both requirement for the problem. Again, we have to discuss about this problem again. We know that if we return back again here, directly we have for the given tan theta, this is the angle of inclination, is a quarter. That means theta equals lambda, tan theta equals tan lambda, both of them equals mu. Then we can get directly the real value of the friction coefficient between the body and the plane, which is mu, and here is equal 4. Now we take this body from the inclined plane to put it in the horizontal rough plane of the same friction coefficient. Then we write it like that. Here is the body and this is the weight and this is a normal reaction. He asks us to find out the real value of both of the force which is pulled, this one pulled the friction, pulled the body horizontally, but this, it's not a horizontal force or vertical force, it's just a force inclined inclined on the horizontal by an angle theta, and its sign is equal 3/5. So we use this 3/5 to get the value of cosine by using the right angle triangle. This is theta and this is right angle. Don't forget this is opposite and this is hypotenuse, and also this is adjacent. Then we get sine and cosine. Now we can write together the equation of the vertical forces and the horizontal forces according to these forces. Now we have r plus f sine theta equals w, or f cosine theta equals mu r, and solve both of them to get the value of both the force acting on the body and the reaction. Now we have a very important problem Let's read it together and now then solve it. A body of weight W Newton. Body of weight W Newton. This is the weight. Is placed on an inclined rough plane as usual of angle 30 to the horizontal. جميل. يبقى الثيتا equals 30 degree. Thank you. Also, if the coefficient of friction is half, coefficient of friction is half. This is mu. Okay. Also, find the force which make the body is about to move upward the plane when the force is horizontal or when the force is acting upward at an angle 30 to the plane. 30 to the plane. طيب أولا تعالوا كده مع بعض نرسم. هو بيقول أنا عندي this is a inclined plane, this is the body, its weight is W. This is normal reaction, and this is W cosine theta, W sine theta, and we will act by a horizontal force. It will be like that. This is the horizontal force, and this is the line of the inclination. Don't forget, if this 30, it will be 30, so we have to resolve. It will be here F cosine 30, and here F sine 30. Now we have to write the equations. First, if the force is horizontally, if the force is horizontally, we can get that F cosine 30 equals, we have mu r here also, equals what? Equals W sine 30 plus mu r. This is number one. Also, R equals the sum of these two forces, F sine 30 and W cosine 30. W cosine 30 plus F sine 30, and this is number two. We need to solve them together. First, F cosine 30, which is root 3 over 2, equals W sine 30, which is half, plus mu, which is half. R, we have to use all the expression of R, which is W root 3 over 2 plus F times of half. Now we get that root 3 F equals W plus half F plus root 3 over 2 W Now we have root 3f minus half f equals w plus root 3 over 2 w. If we multiply this equation by 2, we will get that f 2 root 3 minus 1 equals w 2 plus root 3, then f will be equals 2 plus root 3 w over 2 root 3 minus 1. By solving using conjugate of the denominator, now we get f equals 8 plus 5 root 3 over 11 w, and this will be the value of the horizontal force. The value depends on the weight of the body. That was the first case. Type. What about the second case? The second case tells us that the body will be like that. On the same place, this is the weight, normal reaction, w cosine 30, and this is, we have force inclined by angle 30 again. This is F. So we have to get the component of F. This is F cosine 30, and this is F sine 30. This is W sine 30, and we get also mu r. Let's write down the equation together. First, F cosine 30 equals W sine 30 plus mu r. Secondly, we have the second equation, r plus F sine theta equals W cosine 30. By solving both equations together, we will get that root 3 over 2f equals in one W sine 30, which is half W plus half, which is related to mu. This is half. Now we will substitute instead of r by W cosine 30, which is root 3 over 2 W minus half f. Also we will get that 2 root 3 plus 1 f equals W times 2 plus root 3. So f will be 2 plus root 3 over 2 root 3 plus 1 W. Finally, we get the value of f now, which is 4 plus 3 root 3 over 11 W, and also it depends on the weight of the body. In this problem, it was very important problem. That means if we change the position or the line of action of the effective force on the body, the force will be change its magnitude because it depends both cases on the weight of the body. First, the body or the force was horizontally force. We get it like that, equals 8 plus 5 root 3 over 11 omega. But in the second case, the force was inclined to the inclined plane. يعني عندي two inclination، عندي هنا 30 الأولانية وعندي هنا 30 الثانية. طيب دي صدفة، مش لازم، يعني مش لازم تكون الانجل دي equal الانجل دي by the way. So the force now will be F equals 4 plus 3 root 3 over 11 omega. And this was our presentation today about the friction of the on a rough plane, on inclined rough plane. Don't forget this the important topics or the important definition about what the meaning of the lowest force, what the meaning of the greatest force. Angle of inclination theta is equal angle of friction lambda equals mu, the coefficient of the friction in case of the body is about to move. I hope that we have a good recovering about this lesson. Until the next time, نترككم في رعاية الله، والسلام عليكم ورحمة الله وبركاته.